Okay, we're going to run through drawing tangents to the different conic sections. So as we were saying, conic sections, parabola, ellipse and hyperbola. First thing, going through the different parts, you've got your directrix, you've got your axis, you've got your focal line, and you've got your eccentricity line. That eccentricity line, that is automatically a tangent to the curve. We talked earlier about where the focal line comes up and crosses the eccentricity line. That point is a tangent. So that eccentricity line is a tangent to the curve. And that's the same for the ellipse, same for the hyperbola. So you've automatically got a tangent at that point. If I want to draw a tangent from any other point, so if I take a point here, we'll say for example, call a point P. For this construction, this will work for the three. So this one construction, you can use it for the parabola, ellipse and hyperbola. You join from the point to the focus, and you're going to come off at 90 degrees to that. So I've just set up a line, and I'm going to come off that line at 90 degrees from the focus. So from my focus, I'm just going to project a line out from the focus, and it's going to hit my directrix. Join P to that point will give me a tangent. So that is a tangent to the curve. It's the same down the bottom. As I said, setting up that right angle there will give us a tangent to any of the three curves. We have a second way, and it's a slightly easier way or a more straightforward way. If we take another point, we call it point down here, this point P. This only works for the parabola. I join F to P, and then P back to the directrix. So P to D as we would call it. That gives me an angle. Here's my angle. If I bisect that angle, it will give me a tangent. Now, like I said, that only works for the parabola. So I come along, bisect the angle as I normally would, so take out any distance. And join through. So this is the normal way we would bisect an angle. I bisect gives me a tangent. You could be asked both of those ways. So in other words, you could be asked either or in the exam. This one we say can be used for all three methods. This one only for the parabola, where you bisect the angle. So when I get to my ellipse, again the same thing. This point is automatically a tangent. So where the eccentricity line hits the curve is a tangent. If I took a different point, so we'll say for example a point down here, we'll say, and again it's the same setup. I take point P, I want to draw a tangent, I can join F to P, and once again I'm going to come off at 90 degrees. So I just come off at 90 degrees, draw my line from the focus to hit the directrix. So the line comes out, that gives me the tangent. Done. That is the same construction as I used for the parabola. Also with the ellipse, so you can remember, these ellipses, even though the construction is different, the curve and all the rules apply. And what I mean by that is that I've got a vertex and a vertex either side. I've got a focal point. We have two focal points on an ellipse. Back to junior cert, we'll say for example. So in other words, here are my two focal points. So all I've done is just copy the distance from V to the focal point on one side, copy that distance from V to the focal point on the other side. So now I've got my two focal points. I just get the center of it, and I'll draw my minor axis. So again, I'm just converting this to a standard junior cert ellipse. So we've got our major axis, we've got our minor axis. To find a focal point, to find a tangent, back to junior cert, here's the point I want to draw the tangent to. Focal point through that point. focal point through that point, and I bisect the angle. And I can bisect any of the four. Two of them will give me the normal, and two of them will give me the tangent. So I'm going to just bisect this one, bisect my angle, extend out, and join back. So there is my tangent to the curve. So that's just converting it to the old school ellipse. The normal, if they ask you about a normal is just a line at 90 degrees to the tangent. So in other words, a normal to that tangent is just a line at 90 degrees. So when I come along, come off here at 90 degrees, that is a normal. That's the same for any tangent in parabola, ellipse, or hyperbola. And so again, two different methods. You could be asked either. So again, I've got my 90 degree angle, setting up my right angle. I'll just highlight that in blue to show it. So F to P to the point. So P is the point I'm going to draw on the tangent at. And there's my 90 degree angle. So that angle there, our right angle. Last one then we have is our hyperbola. Again, where that focal line cuts the eccentricity line is a point for a tangent. So the eccentricity line is a tangent to the curve. Very quickly then again, I just take a point. If I want to draw a tangent at that point P, join P to F, and I'm going to come off at 90 degrees. So from that line, let's draw out from the focus at 90 degrees. Gives me my point, join that to P, and that gives me my tangent. So the same construction used for all three. That should be the only way you'd be asked to draw a tangent to a hyperbola.